tangent to a curve is a line which touches the curve in one and only one place. For example, looking at the curve on the screen, an example of a tangent would be as follows. This is the tangent to the curve when x equals 7. It's a line which touches the curve at x equals 7 and carries on. Looking at this curve, the tangent to the curve when x equals 1 will look like this. As you can see, it is a straight line which touches the curve when x equals 1 and carries on. Looking at this curve, the tangent to the curve when x equals 6 will look like this. We've seen in previous video the gradient of a distance time graph gives velocity, and the gradient of a velocity time graph gives acceleration. To work out the gradient of a graph, we consider the change in y over change in x, but that only works when we have straight line graphs. So the gradient of a tangent will enable us to find the gradient of a curve, but only at the point where the tangent is. For example, here's the graph of y equals x squared. Draw a tangent to the graph when x equals 2 and estimate the gradient of the graph when x equals 2. What we need to do here is draw a tangent to the graph when x equals 2. And if we find the gradient of that tangent, it will be identical to the gradient of the graph at that point. The first thing I need to do is actually draw the tangent. So I would get a ruler and draw a straight line which touches the graph when x equals 2. So that's going to be exactly at this point and carries on. It will look something like this. Then I need to work out the gradient of this line, this red line. To do so, I need to pick any 2 points which lie on the line and then work out the gradient. For example, I have chosen the point A, 2, 4, which is exactly where the tangent line hits the graph. The other point that I've chosen is 3, 8, Notice at this point, the first thing I'm going to do is draw a tangent to the graph when x equals 2 as follows. So it'll basically be a line which goes through this point on the graph, but only touches the graph at that place. So it basically touches the graph there. It doesn't actually cut through the graph. I now need 2 points, any 2 points, which lie on the tangent line. I've chosen A, which is at the point 2, 4, and B, which is at the point 3, 8. Notice that B isn't on the curve, it's on the tangent line. Now, as before, I can work out the gradient of the tangent line. The gradient, if you remember, is the change in the y direction divided by the change in the x direction. So I look at the difference in the two y coordinates. 8 take away 4, that's 4. The difference in the x coordinates, 3 take away 2 is 1. So the gradient is going to be 4 over 1, which is 4. Here's another example. On the screen we have part of the graph y equals 5 minus x squared. We want to draw a tangent to the graph when x equals 1 and estimate the gradient of the graph when x equals 1. Firstly, I would get a ruler and line it up with the graph when x equals 1 and draw my tangent line. Then I need to pick any 2 points which lie on the line. So for example, I could choose point A at minus 1, 8 and then B at 3, 0. To work out the gradient of the line, we need to look at the change in y divided by the change in x. So that's going to be 0 take away 8 over 3 take away minus 1, which is going to be minus 8 over 3 take away minus 1 is 4, which just gives you minus 2. And you can see that's quite sensible because the tangent's sloping downwards, so the gradient would have to be negative. And just bear in mind, that is the exact gradient of the graph at the point x equals 1. We often use this to work out the velocity of a distance time graph where the velocity is changing in time. For example, the graph shows the distance travelled by a particle over time approximate the speed of the particle after 3 seconds. To do this, I'm going to draw a tangent to the graph when the time is 3 seconds, because this is distance against time. And once I've done that, I'm going to pick any 2 points that lie on the line. So, for example, I could pick 1.51 and 4.58. Then I need to work out the change in y divided by the change in x. Some people like to do this by drawing a triangle. So they like to represent the change in y like that, and the change in x like that. They like to do that, but it's not essential. We just need to work out the difference in the y coordinates divided by the difference in the x coordinates. So that's going to be 8 take away 1 over 4.5 take away 1.5, which gives us 7 over 3, which is 2 1/3, which is 2.33. This is slightly different to the gradient of the curve, but it's a very good estimate. This graph shows the velocity of a car over time approximate the acceleration of the car after 2 hours. As we've seen, the gradient of a velocity time graph like this one is acceleration. So if I want to find the acceleration of the car after 2 hours, I need to draw a tangent to the graph when time is 2. So that's here. And then work out the gradient of that line. So again, I'm going to pick 2 points that lie on the line. I'm going to work out the difference in the y coordinates divided by the difference in the x coordinates, and I get an answer of 6 2/3, which is 6.67. The acceleration will have the unit. The gradient is 6 2/3, which means that the acceleration is going to be 6 2/3, which is approximately 6.67, and the units are going to be kilometers per hours squared. Here are some questions for you to try. Please pause the video now and have a go, and when you're ready for the answers, press play. Here are the answers. So this is how I've worked out the velocity of the particle. I've drawn a tangent line at the point t equals 3, and I've worked out the change in y over change in x, giving me 1.8 meters per second. Similarly with the second question, where I need to work out the acceleration, I draw my tangent, I work out the change in y over change in x, and I get minus 0.4 meters per second squared.